Hi, I'm Anthony, and today I'm going to be talking about waves. First, let's start off with this question. What is a wave? A wave is a disturbance in some medium that carries energy. Now, what does that mean? Well, think about a pond of water. If you drop a rock into the pond, it'll make ripples. And those ripples are waves that are carrying energy. They're carrying the energy of the rock that you just dropped in, because that rock moves water away so that it can be in the water, and that water moves other water, and that other water moves other water, and so the energy goes out in the ripple that you see, and that ripple is a wave. Now, there are a couple different kinds of waves. There are transverse waves, which are like the stereotypical wave that you would see. They go like this. And then there's longitudinal waves, which unlike the transverse waves, which the energy goes up and down, longitudinal waves, the energy goes from side to side. And that is shown usually by lines, and then when the energy is higher, the lines are closer together. So the farther apart lines are the same as the low parts in the transverse wave, and the closer together lines are similar to the high parts in the transverse wave. And those parts actually have a name. So the low parts, like right here and right here, those are called troughs. Let me spell it right. The little valleys in the transverse waves are called troughs. And then the high parts, like up here, they're called crests. So you have your crests and your troughs, and it goes back and forth. So just like the transverse wave has crests and troughs, the spaced apart parts, or the equivalent of a trough of the longitudinal wave, is called a rarefaction. And then the more pressed together parts, or what would be the crest in a transverse wave, is called a compression. And that's why longitudinal waves are sometimes called compression waves, because they have areas of less compressed medium and more compressed. Now, an example of a transverse wave would be like the ripples in a pond, like I mentioned earlier. But a longitudinal wave would be like if you had a spring and you shook one side of it, that energy would go through the spring and back. Or another example is sound. Sound is the compression of air, and as that moves through, you can hear it. So now let's talk about some of the basic terminology of waves. For simplicity, we're just going to use a transverse wave because it's easier to look at and to work with. So first, we're going to talk about amplitude. The amplitude is the distance from the center to the top of a crest or to the bottom of the trough. It's not both of them together, it's one or the other, but they will generally be equivalent. So say this was 3 meters and this was -3 meters, then the amplitude would be 3 meters because the crests go up to 3 meters and the troughs go down to 3 meters. So you'd have your amplitude at 3 meters. Next is the wavelength. This is the distance from one trough or one crest to another crest, or the distance from one trough to another trough. That's the wavelength. So, and the wavelength is, as a variable, is usually indicated by the Greek letter lambda. I'll write it over here, lambda. It kind of just looks like an upside down backwards Y, and that usually stands for wavelength. So we could say that this is, again, let's use 2 meters, and then this one would be 2 meters. So the wavelength would equal 2 meters. And then the frequency is how many wavelengths there are in a second, which depends on both the wavelength and the speed of the wave. So for our wave here, we have a wavelength of 2 meters. If our wave was moving at 2 meters per second, and since we have a wavelength of 2 meters, then that means that it's going to have a frequency of 1, and then the SI unit for frequency is hertz, which is shortened as Hz. So if this was moving at 2 meters per second, then and since we have a wavelength of 2 meters, then our wave would have a frequency of 1 hertz. So that's the general gist of the basics of what a wave is and some of the terminology related to waves. There's a lot more to waves, which is very important in lots of physics and engineering, but this is generally the basics of what you would need to know to get started. So I hope you learned something, and thanks for watching. I hope you have a good day.